We've just made a correction here that that value there should have been 2. The value of this game is going to be v, so the value of that game was v minus 4. Okay, looking at this from x's point of view, if y plays strategy y1, let's just label these up a minute, may help. If y plays strategy y1 using the normal p and 1 minus p, p1 and p2 notation now, y can expect a gain of 10 with probability p1 and a gain of 1 with probability p2. If y chooses strategy 2, x can expect a gain of 2 with probability p1 and 3 with probability p2. We have here that p1 and p2 will equal 0, so equal 1. And we have that p1 and p2 are greater than or equal to 0, the non-negativity ones we can put in if you want to. If we're going to put this into a tableau, I have my big P and my V. I need how many p values I've got, and I need my slacks, and I need my value column. So, if I put this together, the first, we've said before that V always equals P, so V minus P equals 0 is always the top line. So line 1 over here is a V and a P thingy. So, 1 there, minus 1 there, everything else zeros. We'll see how many slacks we need. We'll put them in when we need to. Line 2 comes from, well, they've done a different way this time. Line 2, if you use this constraint here, sorry, that constraint there they've used for line 2, or used for line 2 this time. That constraint up the top there, that is a 10 going in here, and a 1 going in there. And because, remember, the value of the game is less than that, there's a 1 that goes in here, and I need to make those minus, which I should have said. Because what I'm really saying now is v minus 10p1 minus p2. So I'm putting that in here, the v and the minuses. That I need a slack, so let's introduce a slack variable and put that in. So then for this one here, again I'm going to have a v, a minus 2, a minus 3, and another slack variable. And then my probability is adding up to 1. I need a 1 there, a 1 there. Your book will introduce another slack variable. Okay, these are all going to be zeros over here. And there's one thing here I haven't, it's wrong at the moment, I haven't corrected myself on here, and that's the value of this game. Let me just backtrack here so I get this straight in my own head. That for this game over here, I'm going to scrub that bit actually, we had here the P, the payoff matrix wasn't equal to V, it was equal to V minus 4, because we added 4 on. What we're trying to maximise here, if we rearrange this one, it's P minus V. Let me get this right. Well, they put it in as a 4 over here with this one. When you've added 4 onto everything, they've got a 4 in this position. Okay, Lewis.
Could you do it at the end and maximise it as it is, and then add 4 to your V values you get out on them?
Honest answer for quickness at the moment is not sure. I haven't got enough time to investigate it to do it this way.
Okay.
Okay, bearing in mind we're now 1 minute over the lesson. Okay, if I quickly show you what we've done here, that's what I've ended up with. So the P and the V one, but a 4 in there because that was added on. The constraint, as you would expect with the slack. The constraint, as you would expect with a slack. Your P values, and they put a slack in there as well. Okay, you would pivot on this column here. It's the most negative value in the top. You can pivot on anything down there. You get a solution down here. Now that is the V, but what you really are interested in is V minus 4 from the original matrix. So you need to subtract 4 from the V value you get in this matrix here, this final one, to get the value of the game. So that's undoing that adding 4 at the end by taking 4 off. If anybody wants to work through that one, that's the summary position of there. The only thing I haven't yet mentioned then is dominance. If we just go through that very, very quickly. If we look at that matrix, every X3 entry is higher then every x1 entry, 11 is greater than 8, 14 is greater than 12, 10 is greater than 9. That shows you that there's no point in x ever playing x1. His own strategy, x3, is always better. So x3 is a dominant strategy, and x would never choose strategy x1. So you just completely wipe out that row in your matrix. Similarly, if you're looking at the y's, remember what is lower is better for y. And if you look at this, y3 is always lower than y2. 9 is less than 12, 8 is less than 9, 10 is less than 14. So player y, because y3 is always lower than y2, will never want to play y2. So you can strike that column out. We've already said we can strike that row out, and that then reduces it to a 2 by 2 matrix. That is what dominance is all about. And you can do that fairly early on in a question to reduce the size of the problem. Good luck on Friday.